And welcome back to the CAIA Level 2 video series. Greg Philbeck here with you, and very excited to get started with another topic area as we look in this particular segment to talk about relative value methods. Now, as we look at the must-need-to-know concepts coming out of here, we're going to start by understanding a concept known as co-integration, which is basically something that's associated with statistical pair trading strategy. This does not require any calculations per se, but it's a conceptual understanding of the concept. So again, we'll go through that. Then in terms of calculations, we actually are going to see some calculations emerging out of a commodity relative value strategy known as calendar spread strategies. So we're going to talk about differences in how the calculations would look under a bull versus a bear spread. Then we will talk conceptually about processing spreads and substitution spreads, and we will then focus on a discussion related to foreign exchange relative value in the context of what's known as a carry trade. Carry trade is basically built under the assumption that interest rate parity does not hold in the short term, so there's opportunities to exploit interest rate differential or return differential that can exist in the short term before interest rate parity can likely close down that gap. Then we will move into covered interest rate parity to look at a calculation related to a forward rate, and again, you are responsible for that calculation. So let's get started as we discuss the concept of co-integration. So again, as we start about co-integration, this is a way of looking at relationships that can exist, and really it comes down to, in many cases, the use of co-integration as a part of statistical pair trading strategy. In other words, to be able to identify two securities that have a relationship between their movements and to exploit differences that are occurring. But before you can exploit those differences that are out there, you have to ascertain that those relationships actually exist, which is where we get into co-integration. So with co-integration, what we recognize is a linear combination of two prices as being a stable process. So in order to create a stable process, there has to be no change in the property means, and in statistical, from a statistical standpoint, so no change in statistical properties in terms of means or in standard deviation. Now, we ultimately end up with a stable process if we have co-integration that exists and that those properties are not changing through time. Let's go through and look at an example of how at the surface, as you're looking at a relationship that exists between two stocks, and here you see a plot over time of the natural log of their stock prices, that how at first glance you might not see for each individual stock characteristics that look like they meet the properties of co-integration, that there actually is a possibility of looking at a combination of these two stocks that in fact do exhibit a relationship. In other words, the raw correlation of the returns are not going to be exhibiting correlation or uncorrelated in general. But notice that when we look at a linear combination, in this case, let's say we took the natural log of stock A and then we subtracted out 2 times